Okay, I think we've got it now where everybody can participate and ask questions if they would like. Ahmed, if you want to go ahead and go to the first slide, I think we'll go ahead and get started. So for everybody that's already here, I know we'll probably have some additional people joining soon, but for everybody that's already here, thank you so much for joining us today. My name is Bethany Giles. I'm part of the marketing team here at PowerSys. And before I hand it over to Ahmed, I just wanted to let you all know first that we've just announced the dates for our 3 regional advanced e-motor design workshops. These workshops are in-person, interactive, and they have limited seating. If you're familiar with our annual conferences and events, then you know our workshop is a one-day small group limited seating event, and then it's followed by a one-day conference where we discuss all things related to accelerating electrification. If you're interested in JMAG and how to really leverage the power of massive simulation, we would love to have you join us for this workshop. Registration for the event in the US, if you look at our 2 QR codes over here, there is a registration page in the QR code at the bottom, the bottom right, where you can go ahead and register. If you are in Europe or India and those are more regionally convenient for you, follow along on LinkedIn, because we'll be posting updates when those registration pages are ready and when those registrations are open. That would be the QR code in the top left to follow us on our LinkedIn page. Alternatively, if you don't like QR codes and that's too much, you can reach out to me personally. My contact information is there on the screen and will be sent out at the conclusion of this webinar, and you're welcome to reach out to me and I can get you registered in the right place for the right workshop. So with that said, just a couple of housekeeping things. We have about a 40 to 45 minute presentation for you today, followed by Q&A to fill the rest of the hour. We do have some folks from the rest of our technical team as well as our sales team here in the US that will be available to help answer questions. So yeah, I would say without further delay, let's get started.
All right. Thank you, Bethany, and good morning, good afternoon, wherever you are. My name is Ahmed Shoaib. I'm an EM design engineer at PowerSys, and I'll be going today through the new features of JMAG version 23. Just as a direction of what JMAG is being developed to or for, JMAG is being developed for automating design. What does this mean? Basically, it means that through continuous cycles of optimization, you're exploring a very wide design space. The idea is that without using previous knowledge or 100-year-old knowledge or relying on older methods, you are trying to reach the best possible solution through massive simulation. And this is done through a lot of iterations, a lot of simulations, large number of cases, where at the very end, you're refining your Pareto optimality through this iterative process, and you're reaching a so-called virtual prototype. And at the same time, it's not just EM, we're also focusing on thermal and structural as well at the same time. So the system integration, or like how this whole system is going to work together, is focused on. So a quick agenda on our updates for this version. First, I'm going to go into like global design exploration and optimization features. Then there's a multidisciplinary evaluation, virtual prototyping, system integration, some new materials that we have that we've added to our material database, and then in the very end, some related documentation. All right, getting into it. First, we're going to discuss about the distributed processing of parametric optimization. The idea here is that each case needs to be, we're optimizing each case by itself, and that we're using a metric called distribution efficiency, which basically means how many cases are being distributed at the same time, and we're looking at the processing time per case. Our goal here, if we look at, let me add a laser pointer. Our goal here is basically to push each simulation faster and as fast as possible from that right side to the left side. And we can see that that has already happened between version 22.2 and version 23. So the idea is that you're improving the distribution efficiency of each case so that 100 cases are calculated simultaneously at the same time. Then moving on to the next feature, which was the parametric analysis with large number of simultaneous jobs. We've optimized the file input output. So there was a bottleneck in the disk loading, and that has been optimized for better performance. Ideally, of course, it's going to look like this, which doesn't happen. This is basically due to the Windows reading and writing. And we've seen that through or between version 23 and version 22.2, there's a significant increase in speed, especially when the number of simultaneous cases increases. And this translates to up to 600 times speed up. So as you can see here, we're going into larger and larger number of cases, not just 10, 20, 30. We're looking at the 600, 800 range, 1,000 range at the same time. Then for the magnetic field analysis solver, this has also been optimized with each version. This has been happening for several years now. For small scale models up to 5,000 elements of less than 5,000 elements or less with 33 time steps. We're comparing the result of version 23 and version 22. And as you can see here through the graph, that it's getting a bit faster. The average computation time was reduced by 0.2 seconds, which of course doesn't sound that much. But when you take into account that you're calculating 100,000 cases, that number quickly adds up. So, yeah. Then we've also added optimization with a surrogate model, which basically what it does is that after several generations, it creates a surrogate model, and that sort of steers the direction of the optimization. So the idea of the surrogate model is to omit some of the FEA calculations. So in a 20 generation optimization, an FEA can be run every 4 generations instead of every generation, and that saves you a lot of time. And as you can see here through this graph over here, so the time in hours, if you're skipping every 2 generations, if you're skipping every 2 generations, every 4 generations, you're seeing that the results are quite similar to each other. Every 10 generations might have been off a bit, so we stay at the 2 or 4 range. And if we don't skip, it's more than 4. It's, I think, around 5 hours over here. Here it's around 2.5 hours. And here it's less than 2 hours, or maybe 1.5 even. So the surrogate model will help you, especially if you're thinking of going into 3D optimization. That will be your stepping stone. And then JMAG-Express has also been a bit modified through the previous few versions. A lot of work has been done on JMAG-Express. It's been an extension to JMAG-Designer right now. It's complete FEA. It's not even analytic in any sense, but it's so fast because it uses very small meshes with very small, like with a few number of time steps, just to calculate everything as accurately and as fast as possible. And in this scenario, what is happening is that after running the machine characteristics design scenario, which is the efficiency map in Express, the cooling is also evaluated, and then also additionally a torque ripple scenario is being added to increase the level of detail. And all of these will of course be added. These added scenarios would then be usable in Designer as well. Then result evaluation for multi-case response graphs. Basically, what is happening is that the display of response graphs has been drastically decreased. So what is happening is that we've added like a function where you don't have to load all the cases, you just have to load the response data, and that will enable you to display inside of Designer up to 100,000 cases in under 10 seconds. So if we're looking here at version 23 compared to 22, the reading time, it's almost, as you can see here, it's very small. Then also, this is also applicable in Express, where you have an efficient access to response data graphs. Basically, what is happening is instead of loading all the cases, you're just reading the response data and you're getting the table out of it, and you can then select the cases that you actually want to look at. Because of course, when you're doing this massive exploration, not all cases are of interest, but then over time, you might hone in into the one you need. And then this is a quality of life feature. It's the JMAG-Express scaling. Basically, if you set the gap type as fixed, what it does is that when you're changing the size of the outer diameter, everything is going to scale with it. Previously, what would happen is that you would scale it and then your air gap would be like 10 millimeters. So if you keep the air gap fixed, the JMAG is going to scale everything to that size. And then moving on to the next topic, which is multidisciplinary evaluation. So version 23 expands the available scenarios, and machine topology is not just PMSM, there's induction motor, there's one field synchronous machine as well. And it's been made easier to import DXF files as templates for JMAG-Express. So of course, we've added the field synchronous machine scenario, so you can evaluate the efficiency map, the thermal evaluation, and do a stress calculation as well. All these three scenarios are available for the field synchronous machine. In this scenario over here, we've noticed that the field coil temperature is too high, so we need to reevaluate our design. And this is the advantage of JMAG-Express, is that it can give you a very broad overview. Even if this is mechanically sound, it might not be thermally sound. And that is where, and even also if the efficiency map is what we are expecting, we need to evaluate all three scenarios at the same time, just so that we have a full picture of what is going to happen, and decrease the back and forth of, we've designed this, it's a very structurally sound EM wise, but then thermally it does not meet our expectations or our criteria. Additionally, you can evaluate inductances in efficiency map, and these inductances can be used as response data, and that can be also set as an objective function or a constraint. So you can control the inductance of your machine, or like optimize to a certain inductance value. And then we've increased the speed of the electric field analysis, where here we're evaluating cases with a large number of conductors. And basically, the time is reduced about 1 second for between version 22 and 23. Again, this number does sound very small, but if we look at the grander scale of things, where we're mainly focusing on 100,000 simulations, 200,000 simulations, even more, each second adds up, and we're optimizing for that. And as you can see here, each version 23 has better results or has less processing time compared to version 22. The same for the structural analysis solver. You can see here, especially with the increasing number of nodes, you might see some outlier cases or cases where the processing time is a bit higher. But again, with version 23, these same cases were tested, and we've seen a drastic improvement. And then we've added a feature where you can easily add your custom geometry as a template. You load the DXF file and you follow a setting guide. There's a tutorial for this, of course. And then you can use this geometry as a geometry template afterwards. And it can be used in JMAG-Express to evaluate the efficiency map, temperature increase, or the thermal scenario, and the stress scenario as well. Moving on to the next topic, which is virtual prototyping. So for virtual prototyping, we are expecting to handle very large, very detailed 3D models. And we're expecting the size of the models to significantly mirror what is happening in real life. So it might not just be the motor side of it, it can also be the casing to include all the leakage effects, all the stray losses that may happen. Although there's the MPP solver can reduce your computation time, and as you might know, we can go up to 2048 cores in parallel at the same time for solving. There's also the problem of post-processing, pre-processing and post-processing. So actually handling that model within JMAG. And we've noticed in some cases where even if the client wants to create a big model, sometimes the processing within JMAG is not helping him. And that has been improved in version 23. If we look here, we have a graph of the number of million elements and the speed up factor. And basically what is happening is that there's a performance of models with 10 to 20 million elements, and the processing speed is basically has been improved for improved usability. And the focus is on models with more than 10 million elements. Similarly, for the multi-purpose file export tool, we know that when you're outputting your files to a CFD software or for NVH simulation, you're usually using very big models. And for the multi-purpose file export, there have been improvements in speed for cases with large number of elements. Then for our next topic, which is system integration. So maintaining system integration basically means that you have an early MVH estimate and a thermal assessment. So version 23 bridges that gap by adding NVH analysis as well as enabling that the data can be easily transferred to system-level simulation software such as Simulink or MATLAB, for example. So here, what is happening is that JMAG-Express can actually, you can resize the model or change the model, and that block, when it's fed into MATLAB, it can create like a direct link. And as you're evaluating your FEA models, those are also reflected into your control block over here. So if you have a direct link between JMAG-Express and MATLAB or Simulink, you can evaluate not just the thermals, structural, thermal, and EM. You can also check your control side as well at the same time. And this is the idea of like the whole system integration where everything is being evaluated at the same time at the very early phases. And then as well, Express can output the forces on the teeth, for example, to a third-party NVH tool to enable co-evaluation of magnetic performance and NVH while studying the magnetic parameters of the motor. And then, excuse me one second, just want to drink. Sorry. Then JMAG-RT also supports temperature-dependent efficiency maps. So you can evaluate efficiency map at several temperatures, of course, with your material data. Basically, the magnet's at 25 here, coil is at 55. Excuse me. Same here, magnet is at 150, coil temperature is 150. And you have these both of these efficiency maps saved into JMAG-RT block, which is then fed into your control circuit simulation. And then vibration analysis using a transfer function. So you can evaluate the motor characteristics and the system vibration at the same time. The evaluation of the system vibration is including the gearbox, inverter at the same time, evaluating the efficiency map thanks to the use of a transfer function, vibration results can be obtained quickly. So the vibrational system is basically just a transfer function times the excitation being happened from the magnetic side. Now, this just going through the materials that have been added. So this this amorphous alloy from Qingdao, I'm not going to try to pronounce this, has been added to the material database at version 23. Here are some of the supporting application application catalogs and function tutorials that have been added with this version to sort of guide you through the new new features. And then thank you for listening to our presentation. We will be accepting questions right now.
Yeah, and Ahmed, there are a few in the Q&A that have already, actually 2 that have been answered and 2 that are still open. Or it looks like actually just 1 that is still open, about estimating NVH for outer rotor motors using JMAG.
Okay. Let me, I'll just go quickly through these questions so that everybody can listen to them.
Sure.
The first question was, for the surrogate model and optimization, I need starting data set so that the neural network works correctly. If I calculate 10 indices per generation, and every 4 generations are calculated with a surrogate model, the neural network has only data set of 30 indices for this generation. Can I specify the first generation, which I want to calculate, and then replace every 4th generation with a surrogate model? The answer basically is yes. You can custom list the generations to be skipped, and it can be specified at different optimization steps. So it doesn't have to be at a particular generation where the skip is being done or where the surrogate model is being built. You can customize that as needed. And then the second question, the one user is simulating an axial machine with 8 poles, 12 slot concentrated widening from the geometry library. He is unable to set the winding phases A, B, and C in the slots. Oh, this is basically a support question. Let's yeah, they even answer. Basically, it's a support question. We can handle that later.
Yeah, I do think there's a couple of more generic questions on the open tab.
Sure. The first one question is, have you compared the force results from Express with Designer? How accurate are those? Basically, those answers are those results are equal. So Express is more or less Designer. It's just using smaller meshes and smaller time steps. But the idea is that the fidelity you're not losing fidelity with that. And the idea would be that both results will be very, very similar. There might be like a 1-2% difference, of course, since you're using a smaller mesh, but the meshes even in Express are very optimized to the focus is where it's basically the focus is around the air gap, where most of your non-linearities are happening. So with that optimized mesh, you're getting very good results. One question is, can we export the EM force map into RT through Express? That I would have to check. Yeah, that I would have to double check. Please send us an email afterwards, just to confirm that. 2 more answered questions. How do you validate the motor with PWM loss capability of in JMAG? Is there any experimental validation as well? So yes, we do have several partners we work with to validate the results using experimental measurements. Some of our results are published. Usually we at PowerSys and also our colleagues at JSOL are at IEEE conferences where we have our work published JSOL has a lot of affiliations with some of the universities back in Japan. So there are a lot of publications that you can check with. And then, yeah, I'm checking if we have any other.
The upcoming events slide, can you show that one? Just one more
Of course.
slide. This is a simple one, right?
Yeah, this is the easy one.
Looks like there's just two more. Oh, no, we have one more question. Have you compared the force results from JMAG-Express with Designer, and how accurate are those?
Yeah, they're basically, as I've mentioned, they're basically the same thing. Express is an extension of Designer. It's basically FEA running in the background, so there shouldn't be any discrepancies. As I mentioned, it's an optimized mesh. It's a very small mesh, yes, but it's just an optimized mesh. It's not a finer mesh. It's more of a mesh. It's basically using method 3 in JMAG-Designer, but it's lowering the mesh count around the outer air regions. It's lowering the mesh count in the top part of the steel. So most of the meshes just focus around the air gap. All right.
We can leave just a couple more minutes to see if there are any other questions. It looks like we've answered. There's one more. Looks like Sign-on's working on an answer to, and everything else has been answered.
Yeah, basically the question was if we can evaluate the NVH for an outer rotor motor using JMAG-23. It's basically the same process as an inner rotor. So yes, you can. All right. Let's just wait another minute just to see if anybody has any additional questions.
Yeah, sure. I will just take this time real quick to let everyone know that a very short 2-question survey will go out at the conclusion of this webinar. It will pop up on the screen and you can answer those questions right away, or you can answer them when they're emailed to you with the presentation and the video. We would like to get your feedback so that we know more about what you are wanting to learn about and what you want to hear about, what's relevant to the challenges that you're facing that JMAG can help to answer. So yeah, let us know in the survey, and we hope to have more webinars for you soon. Looks like you did get a couple more questions.
Yeah, one thing I did also want to add, because one of these questions is being already answered. A recording of this webinar is going to be sent within the week. So please just wait within the week. You will be getting a link with the recording being sent.
Yes, thank you, Ahmed.
Can we make generator analysis with JMAG-Express? Currently, it is more. JMAG-Express is it can work in motor for the efficiency map generation. It works in motor and generator mode. Yes. We have another question. What is the inaccuracy level for PWM loss assessment? So directional statement example, 10% inaccuracy based on different experience, cooperation with aka publications. If you share Q links for publications, that would be great. Please contact us so that we can send you those links. We are because we're doing an FEM and FEA PWM analysis, we're looking at very small values. It's much less than 10%. I think we're looking at the 1 to 2% range. One more question that has been asked is it possible to simulate different types of eccentricity in JMAG-Express? So currently, eccentricity is not available as a default scenario in Express, but can be simulated in Designer. However, you can add custom scenarios by the user, which can incorporate functions available in Designer from Designer into Express. So as I previously said, anything in Designer is in Express because both are basically the same tool, it's just a different interface and a different way of thinking about each one. And basically, you can create custom scenarios to incorporate whatever is missing from Express and is available in Designer into Express.
All right, if there are no other questions, I think we can conclude last call for questions. Of course, it's never a last call. You can always reach out to us and email us, but last call to answer them live. All right, Ahmed, I will let you conclude at your leisure.
Oh, can JMAG-Express evaluate the magnetization fault? It's not a ready-made scenario, but you can add it as well, similar to the previous question. Thank you.